So if you've already tried these, you can check them, just kind of skip around to the questions that you need. But for this first one, we're subtracting, and I have g of x minus f, and I'm subtracting every single piece of f. So that leaves me with 8 minus 5x minus 3x squared, but now a plus x, and then minus 17. You do want to write this in standard form, so you'd put your highest exponent term first. So I'm going to start with that quadratic. So negative 3x squared minus 4x, because negative 5x plus x is negative 4x. And then 8 minus 17 is going to be a negative 9. And that's as far as that would simplify. We do want the domain. So if I list the domain of g first, it would be all real numbers. It's a linear function. The domain of f is quadratic, so it's also all real numbers. That leaves us with the domain of g minus f. And it's still all real numbers. There were no restrictions in this function. F plus p. This one, we're not going to be able to simplify all the way, but f is our quadratic 3x squared minus x plus 17 plus p, which is just 1 over 2x minus 5. And there's no like terms for me to combine. So all I can do is just write 3x squared minus x plus 17 plus 1 over 2x minus 5. We don't know how to necessarily combine a rational function yet algebraically, and that's okay, we'll wait for that in Module 4. But this is what we have when we combine those so far. If I do the domains, let's do the domain of f was all real numbers. The domain of g is a rational function, so we had that issue where the denominator cannot be 0, and the denominator is 2x minus 5, so it cannot equal 0. And we just solve for x. At least with x cannot be 5/2 or 5 over 2. And so that would be an overlap of just the same thing as what g is. So the domain of f plus g says is negative infinity to 5/2 union 5/2 to infinity. All right, number 3, h minus g. Actually, let me put these functions right here for us. So h, sorry, here we go. H is our square root, so square root of x minus 9 minus g, 8 minus 5x. Again, put your parentheses around the g function, whatever comes second, because you're subtracting, and you're subtracting 8 and the 5x, which would make a plus 5x. There's nothing we can do to clean that up any further. So we're going to have to leave it the way it is. You could rearrange the order of it, but we can't combine any more terms. So we do the domain of h first, and that's our square root function. Our square root said the inside of the radical has to be greater than or equal to 0. So greater than or equal to 0 would be x minus 9. Since that's what's inside. And I solve it out, so x is greater than or equal to positive 9. There's our domain. The domain of g was all real numbers because it's a linear function. It has no restrictions. And if we combine those two, the domain of h minus g would end up being just 9 to infinity. For f times g, it's a little bit more algebra, but I have f which is our quadratic, and G, so when I multiply those, I'm going to have to distribute every single little piece. So I'd be doing 3x squared times 8, which is 24x squared. And then 3x squared times negative 5 is negative 15x cubed. Because we're doing x squared times x, that ends up being x cubed. Then we move on to our negative x term. So negative 8, or x times 8 is negative 8x. And negative x times negative 5x is a positive 5x squared. Last one here, 17 times 8, you might need a calculator for, but so we do 17 times 8, I get a positive 136, and 17 times negative 5 is a negative 85x, and combine like terms one last time. What you want to do is put it in order from least to, or greatest exponent to the least one, so that'd be negative 15x cubed. And then find our quadratic term. So 24x squared and 5x squared, it gives us plus 29x squared. Negative 8x and a negative 85x is negative 93x. The last one, plus 136. That one had a lot more algebra to do. But if we look at the domains, the domain of f was all real numbers, or negative infinity to positive infinity still. The domain of G, also negative infinity to positive infinity. So the resulting domain of f times G is still negative infinity to positive infinity. All right, h times h. Here's a special one that a lot of students mess up with the domain. So if I look at h times h, it's okay to do it to multiply by itself. I get square root of x minus 9 times the square root of x minus 9. So that's just going to give me the square root of x minus 9 squared. When you're multiplying by itself, the squared and the square root would cancel out and give me x minus 9. So it simplifies down to this right here, and it looks like this has no restrictions. But the main thing that we have to consider is we start with the original functions. So the domain of h was just the square root of x minus 9, and that does have a restriction. We did it up here earlier. The inside of the radical had to be greater than or equal to 0. So now we still have 9 to infinity. And I don't have to rewrite it because we're still talking about the domain of h. So the domain of h times h is still 9 to infinity. The last one, h times p. H was the square root of x minus 9, and times p, which is 1 over 2x minus 5. We're going to have to multiply those. Now, this doesn't have a fraction, but you can make it into a fraction by just putting it over 1. It's implied. So if I multiply fractions, I'm multiplying straight across. That would leave me with square root of x minus 9 over 2x minus 5, because you're just multiplying by 1. So this function stays like this. There's nothing we can do to simplify that. But when I look at the domain of this function, it becomes a little bit more interesting. So the domain of h, we've been talking about, was 9 to infinity. The domain of p, we did this one earlier, but I'll do it again. We had a fraction which said the denominator cannot equal 0. This would be 2x minus 5 cannot equal 0. So x cannot equal 5/2. Or in interval notation. Now when we think about the overlap of these two things, we're saying x can't be 5/2. So let's find that and put our open circle. Then we also find 9. Now 5/2 as a decimal is 2.5, so 9 is bigger and past it. So I'm going to go to 9, and it is bracket, so it's going to have a closed circle and shaded to the right. Now if we look at that overlap there, we're left with just this part. So our domain, let's do this in red again, domain of HP is still going to be bracket 9 to infinity.